Welcome. In last video, we spoke about shoulder planes as joinery planes to create rebates and to do other things. I also mentioned why I don't use them to create shoulders or to correct shoulders. So make sure you check that video. But today I want to talk to you about a completely different function of this tool, which is taking very fine shadings to create extremely accurate surfaces. Okay, and here's a couple of examples of that. With my live students here, we make the level 2 cabinet, which contains this drawer, which for most of my students is their first properly made drawer. And we need to refine those inside surfaces that are going to guide the drawer into the carcass, because we don't want any bumps that might really affect a proper piston fit that gives you the perfect alignments. Also, that's the level 3 chest of drawers, which is a frame and paddle structure. That's much more advanced. And as you can see here also, to get the best possible fit for our drawers, we begin with these inside guides here, which need to be very, very accurately prepared. And for that, we just come inside, more or less like so. You can imagine we come in with our shoulder planes to refine those surfaces. And another example of extremely accurate work that can be performed with a shoulder plane, we find it in the secret miter dovetail. Let me see if I can just take it apart. As you can see, this is the secret miter dovetail. It's this complex form of dovetailing which results in just a clean miter. I'm just not going to close it all the way now, but you get a very, very sharp corner and no hint of all the hidden joinery. So what you can see here is that we have actually the short miters and the long miters. And these long miters can be quite problematic because sometimes they don't close properly or they have small imperfections like bows and Mr. David Charlesworth would use a kind of a jig, a 45-degree jig like this one here, just much bigger than that. And he would come in with a large shoulder plane right up to the dovetails, and he would use this perfected surface to refine the cuts. And for this, you need indeed very thin shavings here, and you need a very flat saw. Now, the issue is we have a problem with this type of shoulder planes, and you will see in a minute. If you've seen the previous video, I demonstrated that by the time we get to working tension here with our locking mechanism, the sole of our shoulder plane becomes a little bit, you can see it becomes bumpy. So let's see why it's that, and then we can tune our shoulder plane to work as well as possible. So as you can see, all of those planes from different manufacturers, they have one thing in common. Okay, they're different models, but all of them, they have this spin wheel mechanism here. You can see this spin wheel mechanism that we find it in all of those planes. It's extremely dangerous, actually. It is so powerful that will create much more tension than you actually need, and they end up distorting. If over tightened, they end up distorting the sole of our planes. And this is a great example. This is a very, very fine plane by Thomas Lie-Nielsen. It is made from bronze, and it is an amazing material, bronze. It is long lasting, it will never break, but it's rather soft and it bends. So students have been unsupervised and they just over tightened this plane, and now it's nowhere near flat. I think you can see and hear how completely distorted this plane is. It still works, and its main function nowadays is to show the extreme power of these mechanisms. So I'm happy with it. We still use it for chamfers and many things, but not for accurate work. Okay, and the same thing would apply to all of those other planes. Uh, if you over tighten this, you will distort the lever cap, and you might even distort the sole of the plane. And so please read the instructions of your manufacturer. They've put together lovely, very well made instructions. All manufacturers do, and all of them tell you that you should never over tighten this mechanism. Okay, some of them they talk about half a turn past the first contact tension. Others, like in this case, they talk about only 1/8 of a turn. Okay, and I'll show you exactly what I mean with that. This type of plane, the shoulder plane, the side rebate plane, they're designed to work with the corners here, and as you can see, we have this very thin area of metal. Okay, this very thin area of metal, it's very flexible indeed, and it will just bend out and remove all flatness from the sole. And the manufacturers need to flatten this surface before they install the blade. That's why, if you see, now I'm going to just remove all the working tension. Just I'm getting here right at first contact, so there is no tension on the mechanism, but just the beginning of a contact here, and I can see this is absolutely flat. Okay, there is no light coming through, and I couldn't be more pleased with this amazing Veritas shoulder plane. It's the large one. I love it to bits, and I can thoroughly recommend it to you. But now, regardless of the who the manufacturer is, as long as you start applying tension, and I'm gonna go right at working tension, which is 1/8 of a turn, this thin area will distort, and all of a sudden I can see it, and you can hear this click. Okay, this is clicking about because there is a high spot here. So if we want to take the thinnest possible shaving with this blade, we're gonna need to dress the sole with the blade in place. Okay, you can do you can do almost everything for joinery and thick cuts with this problem, and it's gonna be totally fine. The issue comes when you try to do the finest possible correcting shavings. We have a fine distortion here. It probably is about 1/10 of a millimeter, which is totally fine, but you're not gonna be able to remove shavings thinner than 1/10 of a millimeter, quite possibly. Maybe it's a little bit less than that, maybe half a tenth or 2/1000 of an inch, between 2 and 4/1000 of an inch. So when we are trying to take the thinnest possible shaving and leave behind a highly flat and corrected surface, then we're gonna need to dress that, and that's what I'm gonna do now. So to flatten the sole of this plane, the first thing I'm gonna do is just to take back the blade to make sure I just don't damage it, but I'm still at full working tension. Actually, I think you can see here I have two Sharpie marks. Number one would be first contact tension, so we cannot work in this situation, but 1/8 of a turn, as the manufacturer suggests, this is my full contact. So this is the way you can record this position to come back to it every time. Okay. And now just let's go to another workbench because I never do metalworking in my primary workbench. I would usually do it somewhere else, but really, uh, yeah, today we're doing it here in one of my students' workbenches. Usually, I would do it in my sharpening station. Anyway, so the first thing I'm gonna do is just to paint the sole to make sure. This is very similar to dressing a plane's sole. Okay. So now we're in a position to see what's actually happening to this. So um, I'm using float glass, 15 millimeter float glass. That's very thick. It's going to be very stable, and it's inherently flat because of the way it has been manufactured. Okay, but it needs to be solid float glass. All right, and then on top of it, I have a very interesting kind of abrasive. It's made by 3M. It's self-adhesive, which makes things very easily, and it's specialized for this kind of work. So I'll give you a link down below. It's extremely expensive, so I just wouldn't use it for average work or woodworking. But for better working and to do this kind of thing, I like it very much. There are other options available, but this one it's good. So first of all, I'm just gonna take a few strokes very carefully. Of course, you need to do as little work as possible to avoid introducing distortions and defects into the squareness of this tool, okay? Because this tool is designed to work with this corner, so that's an important part. So I'm going to be very careful and very deliberate. I'm applying pressure right where I want to do most of the abrasion, and I'm going to pull back very carefully. That's the first movement. So you can see most of the abrasion is happening here where we want to affect. And we have some scratches being done in that position and also at the back here. So that's going to take no time at all. But I think that shows very clearly that there is a bump, and here we have no registration yet. So let's do a little bit more work. As you can see, it's not really much work what we have to do. And please do not think you need to do this unless you really find problems of guidance in very thin precision work. I don't want anyone to come to me and say, "Hey, my plane is working very well." So, yeah, that's only for those who really want to get the best possible results with stain shavings. Okay, so I'm nearly there, and it's been, I think, under 10 strokes, and I'm nearly um, down to flat. Just a little bit more work. This is 180 grit sandpaper, and it's doing an excellent job. And I only pull because I feel more in control here. You could lubricate the paper. I choose not to. Nearly there. So, a little bit more. Some shavings there. Almost done. Okay. You will find lots of information on David Salsworth's 3 books. He passed away a few years back, but his books remain and all the knowledge is in there. He will tell you everything about how to do this properly if you need more information, or how to use this type of plane for the most refined possible work. So I think I'm done now. And so I'm going to remove the plate, I'm going to sharpen it, and then we'll try and get the thinnest possible shaving with this plate. Okay. All right. So let's remove the cap and blade. Always very carefully those corners must be protected at all cost. Okay. That's why I would never use a side rivet plane, a side rivet block plane as my general go-to block plane, because I want to protect those corners, and there is a tendency for them to get nicked when I just put it on a tool well, for instance. I'm gonna remove particles of metal. You could hoover them away. That could be great also. And if you need to, I don't think I need to, but you could just come here with metal polish and steel wool and perfect this surface to get a very smooth running surface. That's something I'll show you one day. We do it to all of our planes here, and it makes a significant improvement in the glidance of the planes. So we don't need to lubricate them, never. Right. So I'm gonna be sharpening this plane with this excellent Lie-Nielsen honing guide. And there are other options available because this one is rather expensive. It's difficult to actually to justify the cost of this tool, but it's the most versatile of all, and it will do an excellent job in sharpening. If you go to my list of recommended tools, you will see other models by other manufacturers that are quite interesting. So that's my projection here. Yeah, and I'm ready to go. So that's not gonna take much work at all. I'm just gonna flatten this stone. Let me just set this aside because I don't want it to get damaged or rusty. Yeah, that's one. I'm going to flatten the other one. I love these ceramic waterstones because they need no soaking, and that's fantastic. Just let me take this plane apart because I'm not comfortable with it being here. Yeah. All right. So that's 1,000 grits. I think, yeah, that's plenty working off to fill a small burr. I'm gonna retract a few millimeters to increase the working angle. And I'm making a micro bevel here. So as you can see, that's not a full explanation about sharpening. That's a much longer video, quite possibly in my online woodworking school, where we'll have time to explain everything in detail and get you from day one to get the tools as sharp as mine are. Sharpening should never be a mystery or something left to years of training and skill, I think. Okay, I'm gonna just remove the burr, and this is a 12,000 grit stone. So I'm thinking, no, I'm not thinking, I'm sure we're gonna get a perfect finish and razor sharp blade. Okay, so some camellia oil, and we're ready to go. Okay, so I have my blade completely installed, very well balanced. So everything is set and ready to try and take the thinnest possible shaving with it. The first thing I'm gonna do is just to remove a little bit of blade until I get no cut. So now I have no cut whatsoever. And I'm gonna start advancing the blade. That was the backlash. Now I start advancing until I get the first cut, which is here, I think. Yeah, that's even a little bit too thin. Let's see if I can manage and take a. Yeah. So that is quite possibly the thinnest possible shaving you could take from this plane. It almost floats in the air. And I can take a continuous shaving. Let me start again. And that's working beautifully. And it's so satisfying. So satisfying. Now we could try and create a reference edge, perhaps on a smaller piece, and see that we can really get down to an outstanding level of precision with efficiency and with ease. Okay? I think that demonstrates that you can really get very, very precise with this type of plane to do the most possible accurate job that you can ever come across. So, that was a very specialized video today, but I think from time to time you deserve also non-standard things. I hope you liked it. I hope you'll give us a thumbs up and subscribe to our channel to get not only this super specialized kind of content, but also more general content like how to sew straight to a line or this kind of thing. Um, I just wanted to reinforce this idea that I don't care who the manufacturer is. If you want to take that sort of shaping, you will need to improve the sole with the blade intention, but it's not really necessary for most work. Okay? Okay. So, see you next week.